just do one last check to make sure I don't need to get somebody admitted. All right. Okay, so let's see. So where did we leave off last time? Did we start looking at this translation? I think we were looking at it on Adam here, right? So here's a Python program that we're all familiar with, and this is when we started working with scoping rules. So, I mentioned that all programs begin and end with main. So we call our main method. Here's our main method. It has print hello world in it. The Java equivalent to that looks like this. Java is built to be a object-oriented language. So you're going to see everything embedded inside of a class. No, there's people face to face, Jason. If you are sitting in the other room alone, look at the board. we are across the hall in S109. So face-to-face class will meet in S109. No, I think a regular thing. Yeah, we had a double booking in the 118 for the class before this. Dr. Locklear and my class were supposed to both be in there. So I came over here, and since my class after this is in here, I'd rather just stay in here. So we'll figure it out. All right, we need to find a way to seat him. We might have to use that table in the back. We do have tables back there. We might need to have is there a chair there? All right, drag a table out or something, or whatever. I think. Oh, no worries. Did you read the board finally?
I did, yeah. I don't know what happened.
Yeah, but there's that circular table. You can drag whatever you want off if you want to sit at a table. And then what I suggested is, if you can't see the screens very good, because even with glare and stuff, just get onto the Zoom thing and turn the sound off. But you were already on Zoom, so you're already ahead of the game. Okay, yeah. So since Java is an object-oriented language, this idea of a class is going to come up very often. Pretty much everything we do is going to be embedded inside of a class, which is very similar to what we saw last semester in Python, where when we got into object-oriented programming, everything was in a class. Okay, so forget about some of these leading up things here, but all programs begin and end with main. So in Java, we have a main method, and it has to be written this way. Exactly. The only thing you can change from this line is you can change the name of the parameters passed in. You don't want to call it args, instead you want to call it elephant. You can, and we'll talk a little bit about this here in a second. To print something out in Java, instead of print, you use system.out.println and give it its thing. If you want to print it and have it stay on the same line, you can say system.out.print. So println prints it and kicks it down a line. Print just prints it to the screen but keeps it sitting on the same line. So we should see woot world followed by LOL with hello immediately following it here. So I'll go ahead and save this. Again, Java is a compiled language, so we made a change. We need to now recompile it. So I'll recompile our CSC200 Java test using the Java compiler, JAVAC. You won't have to do this commonly. We're going to be doing our code in Eclipse soon enough, but I'm just really driving home this point of the difference between an interpreted language and a compiled language. Remember, Python was an interpreted language. So when we ran it, we just ran it through the interpreter or hit the little play button on the Python tool we used. In Java, we technically compile it first and then run it. So compiling means translating it into a low-level language prior to runtime. All right, so I'll compile it. Nothing happens. So what it just did is it overwrote that .class file. And then to run it, I just run CSC200 Java test. That's the name of the class file I created. That's the Java bytecode. That's the low-level language that's understood by the Java virtual machine. So there's my woot world. And then notice here I have LOL hello. And this little thing here is because it's still on the same line. I didn't kick it down a line after that. That's where this thing came from. All right, so if you want to just do a print, you can do that to not kick it down a line. Similarly, you can include a \n at the end of a print, and that will kick it down the line. So there's your woot world, LOL, hello. \n is just the escape character for carriage return line feed. It's actually just line feed, but most operating systems treat it as carriage return and a line feed. Think of it as just pressing enter. This is not a Java thing. This is any programming language. Supports \n. Okay, so where did something like this come from? Well, I'm going to start off by just showing you a couple of examples here. So the starting off point is, what is this guy, this string array elephants thing? So an array, anytime you see these opening and closing square brackets in Java, think of that as kind of like a list in Python, a collection of stuff. In this case, it's a collection of strings, because Java is a strongly typed language. So any variable we have in Java must have a type associated with it. So if I want to create a variable int a is equal to 7, I have to do that in Java. I can't just say a is equal to 7 like I could in Python. I have to give it the type that this variable is built to hold, because it's a strongly typed language. In Python, we pretty commonly would have created a variable with the intention of only putting a number in there. But now in a strongly typed language like Java, C#, C++, C, we have to specify the kind of value it was built to hold, which I think is better, because that's forcing you to make those decisions ahead of time and, you know, doesn't allow you to. So if I have my int a is equal to 7, and then I try to say a is equal to hello, the next line down, and then I go and compile that, it screams at me. It says incompatible type. A string cannot be converted to an int. Why? Because I'm trying to shove a string into something I defined as being capable of holding an integer. So I defined a variable named a, set it equal to 7. Now I try to overwrite it with something that is not an int. All right. But let me give you a little bit of background here on this stuff up here, and then and where it came from, and then we'll dive into the memory, what we just saw, the memory, asking questions and repetition side of Java. Because remember, I mentioned that, you know, 100% of programming languages will have facilities for variables, conditionals, loops, and functions. And once you know how to do those things in a language, you now pretty much know how to use the language, and just through some practice, you'll get past the idiosyncrasies of the language and that kind of stuff. All right, so, sorry about that. So let me do this. I'm going to go ahead and I'm going to say for int I is equal to 0, I is less than elephant dot length I plus plus, and I'll say system .out.println elephant at bucket I. All right, so let me show you how this works first. First of all, I'll say this is probably something you're going to very rarely use, but I'm just showing you why it's there and what the purpose is. All right, and then I'll kind of show you where it came from. All right, so I compiled it. It's happy with that. Now, if I just go ahead and run the program normally, nothing comes out. I don't get into that for loop. But if I say cat, dog, woot, notice that it now shows me those command line arguments. So when you run a Java program from the command line, this is me running it. Java, the name of my program. I can then give it some extra arguments if that was something that would play into my program. You know, like, well, I'll show you an example here in a second. But so I gave it 3 things here, cat, dog, woot. Those things got loaded into this collection of strings automatically. And I went through that collection of strings here, printing them out. Go ahead. Oh, Java has something as input as well, because this is prior to runtime, right? This is me when I first start the program, feeding it some stuff. Yeah, you can also ask for inputs during the program, but this is like getting the ball started. You know, so if I want to do something like, here, let me just give you an example of some use of that. So maybe if I say if, actually, let me just do it this way. All right, so what I'm going to do is I'm going to expect that I read in 2 things. Let me go ahead and run it here real quick and show you. So I'm going to say 5 and LOL. So it's now printing out LOL 5 times. I run it again and I say 20 woot, I get woot printed out 20 times. Just an example of how you might use command line arguments. So what did I do there? I created a loop that started off at 0, kept going as long as I was less than the integer version of whatever was the first element in my list. Don't worry about some of the, we'll talk about integer, not percent and stuff. Don't worry about the details of that right now. But the logic here is I'm going to loop through the number of times that I specified here. And what am I going to do each time? I'm going to print out this guy. So that's what I did in my logic here. Loop through and print out whatever was at bucket 1. If you were to use command line arguments for your program. Go ahead. Elephant is the name of that variable. This is just like Python where functions take in parameters, and this is the name of that parameter. I could call this guy, args is the common thing for it. You can name it whatever you want. Yeah, this is the parameter to the main method, the main function. But it has to take in a parameter. Yeah, but we'll talk about functions specifically. Yeah, don't worry about that right now. I'm just kind of giving some explanation for, you know, what this extra junk is here for. But like I said, especially with modern programming being mostly graphical user interface type stuff, not that often are you going to be giving command line arguments to stuff. So you very likely won't use this, but it is there for you to use, and it is still used. But it really came from something a long time ago where if I, let me just create another file. So we'll We'll save this as CSC250 test.c. So I'll do an include I'll just do this quickly. All right, so this is a C program, so something from the late 60s. Notice here that this looks pretty similar to Java. You know, at a glance, it doesn't look substantially different. Instead of system.out.println, it's printf. It's still called main. It doesn't, so this is the return type. This guy returns an int instead of void. We'll talk about all that stuff. But this guy takes 2 parameters instead of 1. I'll talk about that here in a second. But just real quickly, let me show you this real quick. So I'll go here. I'll say GCC CSC200 C test. Oh, sorry. All right, and that gave me a file called a.out, which is the executable. So I'll just run this. So it said the number of arguments passed was 1. If I run this again and I say LOL woot, it's now going to say 3. The 1 is because in C, it also passes in the name of the program. So a.out is actually the first thing passed in. So if I come in here and I say %s and I say argv at bucket 1, well, let's just do argv at bucket 0. I won't change any of the rest of it. That's the first command line argument, was a.out. If I say give me the, well, here, we'll just do %s. I'll do the first and the third since I'm passing it 3 things. And I'll kick it down a line so it stops doing that % thing. Oh, sorry. argv0. I'm telling it, here's a placeholder for a string, here's another placeholder for a string, it expects 2 strings, I have to give it 2 strings. So here's the first string that was automatically passed, and here's the third string, woot. Okay, 1968, still had command line arguments. All right, you're looking at a very, very, very old language here. The difference is so this guy, you can think of this as being a string array, similar to what we're seeing in Java right here. The difference is in Java, a array can tell us its own length. So in Java, I can say elephant.length, and it will tell me how many elements are in that array. Just like in Python, a list can tell me its length. In a language, an old language like C, arrays could not do that. So that's why I have 2 parameters. This is the argument count. How many are there? This is the argument values. These are the actual strings. Okay? Now, this isn't something I'm going to test you on. This is more just giving you some context of why you have some extra syntax sitting up there inside of your functions. There's a reason for it. It's not just made up fluff. Okay? It's just not something you'll necessarily use very often. Make some sense? All right, everybody online holding in there all right? We get nothing from the peanut gallery. Last class, nobody from online said anything. I have a feeling they log in and walk off. That's okay, I don't care. I'm recording it anyways. Okay, so in any case, I'm not going to ask you to write any C code or anything like that, but you see that this is some code from 1968. This is stuff from the 1990s, and you still have main, you still have command line argument syntax coming in, you still have for loops. All this stuff came from C. If you remember from last semester, we had that little chart where we said, you had C to C++ to Java, C#, Swift was over here, Objective-C was over here, then you had all your Python-y stuff over to the left. It's all the same. Okay, what we're doing here in the first couple of weeks is we're just kind of, going through and saying, okay, well, Python, a variable in Python was like this, a variable in Java is like this. An if statement in Python was like this, an if statement in Java was like this. Just looking at those similarities. And then after we do it a couple of times, you realize that, oh, okay, programming is programming. It's going to be the same logic as you had last semester. You're just doing it with a little bit different, I don't know, syntax, I guess. Okay, so in the slides here, I gave you kind of a starting template for a hello world program in Java. This would be something you're going to want to kind of memorize so that whenever you sit down to write a Java program, you can kind of just give yourself that starting template and you're good to go. Type out hello world real quick, run it. Now you know you have a functioning program, and then start modifying it to give you your, new things that are related to the logic you're writing. Okay, and again, just as a reminder from last class, the Java language is kind of sort of compiled and interpreted at the same time. It's an interesting language. Where we start off with our Java source, we then compile it, and compilers translate from high level to low level, right? So then we end up with this thing called Java bytecode, which is our .class file, which is then sent into the Java virtual machine, which acts as an interpreter, which converts it to assembly for the local machine. Let's just say sort of, kind of. It actually doesn't have to convert it to assembly, it just runs it, but whatever. And then it's executed on the CPU. Okay, so this is a compiled step. This is kind of an interpreted step right here. And it's fair to call it an interpreted step. That's what it is. It's an interpreted step. And that should, in your mind, translate into, well, Java is probably faster than Python, but probably slower than purely compiled languages that run natively on the computer's hardware. So we could say Java is slower than C++. Java is slower than C# after the first time we run the language. Did you park me in the same place?
Yeah.
Oh, awesome.
Do it though until tomorrow.
Oh, okay.
So in the
So
other place I looked at was like a half hour away. So.
Okay, yeah, no worries.
Okay.
So in any case, we could say Java's kind of slower than those other languages, and Python's kind of slower than Java, but at the end of the day, computers are really, really, really fast, so it doesn't really matter. It's kind of the punchline. Only if you're writing a video game might you really have to or writing an operating system might you really have to start thinking about those kind of things. Okay. So actually, let me go through our, basically it's this slide for how humans solve problems, because I've mentioned before that every single programming language has facilities for variables, asking questions, and repetition. So let's see what these things look like in Java. I think I have some examples in here anyways, but let's just look at them all at once. All right, so we've already seen variables. If I say int a is equal to 5, and then I say system.out.println a. Actually, you know what? Let's just go over to Eclipse to make life a little quicker for us here. Int a is equal to 5. We'll go ahead and print out a here. And there's my 5. If I change A, if I say A plus equals 4, and then I say system.out.println A, I now get the 9, and plus equals is something you saw in Python. Things that you should be focusing on here is the differences. Notice I end each line in a semicolon. If I leave that semicolon off, I get screamed at. There's an error. Notice in Eclipse, it kind of gives you almost like the spell check that they give you on like Microsoft Word. So you can hover over this and it says, syntax error, insert semicolon to complete statement. You know, so one of the things you'll have to get used to doing is like reading those syntax errors and knowing what they kind of mean. But this is going to be one of those things where you have to, you know, convert your mind a little bit, knowing that I have to end lines with a semicolon. All right, so that's some variable stuff. If I want to ask a question, if A is less than 10, notice I don't put a colon here at the end of the line and then indent. Instead, our block structure for an if starts with an opening curly brace and ends in a closing curly brace. So if A is less than 10, I'll say system.out.println. Let's just say woot. That's if it's less than 10. We saw that A gets up to 9. Is 9 less than 10? Yes, it is. So this should print out woot. There's our woot. If I instead add 7 to A, so now it's not less than 10, I'll just get the 5 and 12 with no woot. But I can optionally, just like in Python, add an else to my if. And we'll do an LOL for that guy. So if it's less than 10, print woot. If it's great, otherwise, if it's greater than or equal to 10, print LOL. Right now it's a 12. So there's my LOL. If I change this back to add 4, now it'll print out woot. All right, so notice no colons at the end of these lines with forced indentation. Now, if you remember back to the Python class, one of the things I mentioned is that I like using Python as the first language for many reasons, but one of them is that Python forces indentation, which is very, very, very good programming practice. As your programs get longer and longer and longer, not having that indentation is going to become a problem. All right, you're going, you know, your code is going to become spaghetti code and hard to debug and stuff like that. But let me show you here in a language like Java. It doesn't care. You can write your entire program on one line if you want to. Now, wouldn't you agree that's hard to read? Okay, so one thing that you run into is when your very first language is a language that doesn't force you to format your code reasonably, you end up not thinking that that's important. It's always important whether the language forces you to do it or not. In fact, you'll see with Eclipse is Eclipse will automatically indent for you. One thing that Eclipse does, though, that I'm not necessarily a fan of, so let me just go back to something like that. So I'm going to create an if statement. A lot of people will put their opening curly brace there and then kick it down a line like that. And it'll put it, you know, like, so I'll just go ahead and finish writing this system.out.println woot. And then I'll throw the else in here. Notice that Eclipse does command completion. So as I say .out, I only have to type the first part of the next thing. Although notice it only gave me the print, not the println. But it will help you not misspelling variable names and that kind of stuff. All right, so this is reasonable syntax. This syntax became popular through textbooks. They were trying to save a line or two to get code to fit on a page of a textbook way back before we had everything on, online. So, you're opening curly braces here, you're closing curly braces here, so your block is everything inside there. Not the end of the world, but if you imagine you had a whole bunch of lines of code here, where you can't necessarily see where who this guy is closing. Whereas if this guy was kicked out this way, you see that those two are linked to each other. I think it is visually, it gives you the indention type thing. It's not wrong to have your opening curly brace up there. If some of you have had programming experience before and you're already used to doing that, I'm not taking off points if you do something like that. But my recommendation would be create a block structure like this. I think it makes your code look cleaner. Eventually, once you're used to programming and you're doing this day in, day out, you'll come up with your own style and you'll decide what you love, what you hate, and move on with life. Okay. So questions on, actually, let me show you one more thing with if statements. One thing you were used to seeing in Python is else ifs. So in Java, it's else if, two separate words. And then you'll say something like A is less than 13, print LOL, else. Let's just say print hello. So in this case, it is less than 13. If I kick it to a +7, so this will be a 12. So I get my LOL. If I make this a 71, now I'll get my hello. So this is equivalent to your elif from before. But actually, there's a little bit more to it. In Python, you had a built-in syntax for the else if called ELIF, elif, right? What's actually happening here is these curly braces are not actually required. And I'll explain, let me take them out first and I'll explain why. And then I'll tell you should always use them. All right, so same code, works the same way. An if statement, the syntax for an if statement is if Boolean expression followed by statement. Now, if you only have one line of code, you can have a single statement there like that. More times than not, you're not going to have one line of code. So what you would want your statement to be is a block statement that can hold more than one line of code. My argument is that even with one line of code, using a block statement gives it a better visual structure. The other thing is you're never wrong to use opening and closing curly braces. Let me show you the alternative here. Actually, I'll just steal this one. Okay, so if A is less than 10, well, right now, A is not less than 10, right? I've added 71 to 5, so I'm at a 76, not less than 10. If you looked at this in Python, you would immediately say, oh, so this is going to print nothing. But it actually prints out that LOL. This line here, this statement right here, is not linked to this if statement. The if statement only has one statement associated with it. It can be a statement like a systems out that println statement, or it can be a block statement. So I can do this, and now it is linked to it. But notice that Java does not care about the actual syntax. I'm sorry, does not care about indentation. Java does not care that I have this line here indented underneath the if statement so that it fools us into thinking it's part of it. Because Java's perfectly happy with me having it even up there. But this is still two statements. This is statement 1, ending in a semicolon. This is statement 2. So even as this, the LOL will still print. So where Python trains us into thinking that having indentation dictates what something belongs to, in Java, we use curly braces to create block structures. So think of them as like garbage bags filled with code that all go together. So anything in a block is part of the statement associated with that block. All right, but then we choose to use indentation to make our code look cleaner, easier to read by humans, that kind of stuff. All right, make some sense? So my argument would be always use the opening and closing curly braces. It's never going to be wrong. That way, when you want something to be part of a conditional, you can explicitly make it part of that conditional by just putting it inside of the associated opening and closing curly braces. It's never incorrect to do that. And remember, with programming, nobody's going to give you a blue ribbon for saving one line of code. Every now and then, you might be working on a project where absolute efficiency means something, where smallest memory footprint means something. Thinking about like embedded systems, you know, you're writing some code for a dishwasher or something like that, where only so much code will fit on the little memory chip that came with it. And you know, even though that memory chip cost them 16 cents and the next one up cost them 19 cents, you know, might say, well, why don't you just spend an extra 3 cents and have it? Well, when you start adding that up over millions of units, that starts turning into real money. So they might say, look, don't use a curly brace if you don't need a curly brace, because the storage, you know, every byte of storage might mean something in an embedded system like that. But in a normal computer, we don't care, right? We have 16, 32, whatever gigs of RAM. We're not going to miss it. It's going to be fine. Yeah. You mean this thing right here? Well, okay, there's kind of two pieces to that. Usually on an embedded system, you'll just have the compiled code. So in actuality, it wouldn't actually make a difference. So saving a curly brace won't actually make your code smaller in the end, because it's actually compiled. So you'll end up with the executable. The source code file would have the extra character of a curly brace, plus there is a carriage return here. So this would be 2 characters to have this one line. And you know, if you're using Unicode, that's 16 bits. So that's 32 bits of code you're wasting there. 64 with the second curly brace, assuming you only have one line. 64 bits. I would say it's not a big deal. If you're ever working on a project where it is a big deal, I promise you, you will always already be a very experienced programmer. Will it all make a lot of sense to you? For right now, I strongly encourage you to just always use curly braces. You have an if statement, match it up with an opening, closing curly brace, and put the stuff that you want in there inside the curly braces. Easy peasy. All right, questions about any of that? All right, so that covers conditionals. Already looks pretty similar to Python, just gonna have to get used to the whole curly brace thing and the semicolon thing. Okay. Loops. Well, we can say, let's just back it up here. Start off A at 0 while A is less than 10. System.out.println A. We'll say A plus equals 1. I like to put spaces in there, but Java doesn't care. So this is going to be a pre-check loop. While A is less than 10, is 0 less than 10? It is. So since that's true, we'll print out the current value of A, add 1 to A. So the print out a 0. A is now 1. Is 1 less than 10? Yep. Print out a 1. 1 becomes 2. Is 2 less than 10? Yada, yada, yada. And there's our while loop. What do you mean? What's the driver class? As far as we're concerned right now, since we're not writing objects yet, just houses our main method. All programs begin and end with main. That's what it does as far as we're able to understand right now. We'll talk about it in a few minutes when we talk about functions, but this is the return type of this guy. But we'll talk about that. Java is strongly typed, so when we have anything that involves a type, we have to define it. In Python, we could write a function and it just returned whatever value we returned. And this one, we have to say, do you expect to return a value? In this case, no, we don't. Void says, I'm not going to return a value. If we expected to return an int, we'd put int here, but we'll write some functions. So we'll see that in action here in a little bit. All right, so this is our loops here. So this is memory. So if we're just kind of filling in the gaps here, this is memory. This is asking questions, was our if A is less than 10, system.out.println, woot, else system.out.println, LOL, something like that. And then we have repetition. So here's a while loop repetition. One of our go-to loops in Python was like for I in range 0 to 10. So remember, I'll just put it in a comment here. So remember something like for I in range 0, 10. Print I, something like that. So in Java, this would be a for loop. So we'll say for int I is equal to 0. I is less than 10. I'm going to say for right now, I plus equals 1. And we'll do a system.out.println I. All right, so this will take I on a voyage between 0 and 10 non-inclusive. So it'll take it to 9, just like range does. So there's our 0 to 9. Make sense? Now we can also write functions. In Java, we'll go ahead and write a second function inside of our class. So just like in Python, when we had a class, we could have a whole bunch of functions in there. So I'm going to write another function. It's going to be inside of the class, because this curly brace, this ends the class. This curly brace right here ends the main method. You can see that lines up to our main method. And notice in Eclipse, if you click it, it puts a square around the corresponding one. So it kind of shows you where they connect. All right, so this ends the main method, this ends the class. So in between there, you don't put another method inside of a method. Remember, that was a common mistake some of you made last semester. You just create a method and you start throwing other things inside of it, including other methods, and things went south pretty quick. Think of our class as being like a bag that holds a bunch of functions, a bunch of methods. And we can put a bunch of them in there, they just can't be inside of each other, okay? So what I'm gonna do here is I'm gonna have another method. So let's just have, for right now, don't worry about why I'm doing this, but I'm going to say static int add nums, int A, int B, and this guy will return A plus B. Okay, don't worry about the static part of this. We'll talk about that in depth when we get to it. Static versus non-static methods require some explanation, as well as some context. So right now, it's just all your methods will be this until they're not. All right, but the syntax for a method in Java is type method name, opening parenthesis, comma, delim params, closing parenthesis, opening curly brace. Let's just call this logic, closing curly brace. And this is the return type. So this method has a method name. It returns a certain kind of body or a certain kind of value, potentially void if we don't intend for it to return anything. It will take a comma delimited list of parameters, just like in Python, except those parameters require types. If I want it to take 2 integers, I have to say this guy's going to take in 2 integers. If I want it to take in a string and a char, I have to say it takes in a string and it takes in a char. Where in Python, I could just give it 2 variable names and just, hope that I knew to call it with the right stuff. All right, make sense? All right. Oh, by the way, somebody before next class put on Slack, I need to bring your yellow belts, right? I'm gonna hand out yellow belts. So you came out of the first class and now you've earned your yellow belt. All right, so in any case, this is the generic, and this guy here, this is a multi-line comment. Eclipse kind of puts the extra asterisk in there just to kind of block it off. But a multi-line comment in Java is front slash asterisk, and then you stop the comment by saying asterisk front slash later on. So then you can put as much stuff in between as you want, and that's a multi-line comment. A single line comment is like the single slash slash like this. This is stuff that will not get executed by the program. This is human eyes only. This is just giving me a little reminder. This is just including a little stuff in here for you to reference. All right, so the general syntax for a function looks like this. Go ahead. Yep. I'm going to call it here in a second. Yeah, so this guy returns an integer. Its name is add nums. It takes in 2 integers as parameters. And all I'm doing is I'm adding those 2 numbers together and returning the result as an int. So I can't do something like this. I can't say I'm going to return hello here. It's going to scream at me and say, oh, you told me your return type is an int. Why are you returning a string? Type mismatch, cannot convert from string to int. Similarly, if I say I'm not going to return anything, if I put void there, which says, look, my function is going to do something, but it's not going to spit an answer out. It's going to just perform a task, maybe put some stuff on the screen, whatever. Remember last semester, that thing about there's a difference between returning a value and printing a value? Okay, but if I advertise that this guy's not going to return something, I better not return something. So in this case, I'm returning something and saying void methods cannot return a value. So I'll go ahead and switch this back to int. Change this to a plus b. Go ahead. No. Well, not directly. You can return an object type that you invent that has multi. So you can create a class called people, or person, that returns a name and an age and an address, right? Because you're actually going to return an instance of person which contains those 3 pieces of information. No, not directly. Some of the newer languages you can. They return them as something called a tuple. just a list of return types, but not in Java. Okay, so here's a function that knows this is an untapped resource. I haven't called it yet. It knows how to add two numbers together and will return that result. So up here in main, I'll go ahead and call upon that. So I'll just go ahead and say add nums, and I'll pass it 3 and 5. All right, so what will we expect my last line of my program to print out or to have on it? Okay, well, we don't see the 8 anywhere. Last thing was a 9. Why? Well, I returned it here. I called it here. So what I have highlighted there does boil down to an 8. What am I doing with the 8? Nothing. So if I want to do something with it, I have to capture it in a variable, or I can print it out. I can say system.out.println. I can print out whatever that function boils down to. And now I'll get my 8. So there's my 8 right there. Similarly, I could store it inside of a variable. I call this maybe guy int answer. Pass it 33 and 51. And then I can do a system.out.println answer. So there's my 8 and my 84. So I only get to use the value that's returned by a function if I do something with it. I either print it or I store it somewhere, whatever. Same thing as in Python, right? Python, if you have a function that returns a value and you choose not to use it, well, in Python, what would it give you? The default was a none. Remember that? Yeah, because like, look, you told me to print out what I got, and I got nothing from this guy. With a strongly typed language, we're a little bit more controlled because we have to explicitly say what we are going to return. If you say you're going to return an int, for example, so let's say I do that. I've advertised to Java, I'm going to return an integer. I've taken in 2 ints, I added them together, I stored the result inside of a variable called C, but I never actually returned an integer in here, right? Java's not happy with me. It's going to say, hey, this method must return a result of type int. You told me you were going to give me an int, and you didn't. So I either would need to change this back to void, and now it's okay for this not to return anything. The C here has a little orange line underneath it because it's telling me you created a variable that never used it. Are you sure you wanted to waste your time creating that variable? But it's not illegal, it'll run. But we do have another error up here now because I'm trying to store the result of add nums inside of answer, or I'm trying to print the result of add nums here when add nums now returns nothing. That also makes Java unhappy. Okay, and this is why I think this is better for structured programming, is because as a programmer, we want to be explicit. And in this case, if you're going to return a value, you have to tell Java you're going to return a value before you get started. And then you have to follow through by actually returning that value. If you plan on not returning a value, Java forces you to say, look, if you're not going to return anything, let me know. You got to say, I'm going to return nothing, void. And then you better not try to return anything or Java's going to scream at you. So this is kind of like self-policing, but Java forces you to do it. You're going to find that this is true in C, C++, Java, C#, Swift. Pretty much any strongly typed compiled language is going to function this way. So this is not a Java thing. This more comes down to the nature of strongly typed compiled languages. We're almost all compiled. In fact, as far as I can think of right now, mainstream compiled languages are all strongly typed languages. So those two words kind of go hand in hand, just like interpreted and loosely typed kind of go hand in hand. All right. So Java requires you to define variables with types. Java requires you to define functions with their return value. And I'm using function and method interchangeably. If you remember from last semester, prior to object-oriented programming, we might have called it a function. Once they're embedded inside of a class, the new naming convention is to call them methods. It's the same thing. So call them whatever you want. So the words mean the same thing. It's a chunk of code that does something and potentially returns a value. Okay. Yep.
So in your code, you are calling but you're not calling anywhere.
Yeah, all programs begin and end with main. Yeah, so correct. We forced the issue in Python, but we did see that in Python. If I flip back here, main was still present in Python. It was just sort of kind of hidden from us, where we had this thing where there's a built-in variable called underscore underscore name, and one of its possible values was underscore underscore main. So this is something that is built into Python. It was just not as obvious to us, not policed by us. So I kind of created, when we started working with scoping rules, I removed that global environment from us so that we had, functions that owned their own variables, then they couldn't be used in other functions. That's when we did this. But ultimately, if we just assume that Java does that for us, that part, that means all programs begin and end with main. So this main was automatically called in Python because we forced the issue, where in Java it happens. Pretty much all of our modern languages happen. You saw me write some C code earlier, and when I ran it, I mean, I never called main directly. It called main itself. That's what it does. That's considered the start of the program. Make sense? All right. So so there's some examples of repetition. There's some examples of functions being called, and functions can certainly have repetition in them, just like any other. What time are we out of here, by the way? 12:50. Okay, we're good. All right, so these guys can certainly have stuff in them, just like in Python. Okay, but what are the big things we've seen here? We've seen that we have to throw the types in front of variables when we define them. We have to throw the types in front of parameters when we're writing functions, and we have to throw the types in front of the functions when they're being returned. Okay. All right, so let's go back here. So that was just how humans solve problems. So this is us. We just basically define the entire Java programming language in terms of Python by looking at these three things. So now it's a matter of practice, right? And learning some of the built-in things in Java that maybe make life a little easier for different things. All right, so we've already talked about loosely typed, strongly typed, interpreted versus compiled. Languages we've worked with, we've talked about Python and Java. Now, when we think about compilers, I think did we look at the Hello World program in Linux last time? So a compiler needs two different things. We need to know what architecture we're targeting, because remember, the job of a compiler is to go from a high-level language to a low-level language. Well, the low-level language is defined by the processor. So an Intel processor understands a certain low-level language. I think I mentioned last time, maybe the MIPS processor understands a different low-level language, even though they're not common processors for us. So when somebody writes a compiler, they're going to be going from, did I mention MIPS in here? Was that a different class? Is that like a made-up word to you right now? So if you go, actually they still exist today, but if you roll back 25 years, Intel wasn't the only guy in the field. Today we have AMD as well, but they're compatible. AMD and Intel have the same low-level language. There is a couple of magic tricks that only exist on one or the other, but they're largely compatible with each other. But there are some other manufacturers of processors. One of them is called MIPS, which today is used in a lot of embedded systems. So, not like your general purpose computer, but they might be used in like your smart toaster, stuff like that. Apple makes their own silicon now, so all of their phones and stuff have their own version of their A chip. And now they're going to start shipping their MacBook Pros with those in it soon. We'll see how that goes, because I mean, there's some history there where You know, I think Apple became as strong of a company as they are today because they moved away from a proprietary chip like the PowerPC to an Intel processor. And now they're going back the other direction, and well, I guess we'll see. But in any case, when you're converting between a high-level language and a low-level language, the low-level language you're targeting has to be compatible with the processor it's ultimately going to run on. So one of the things the compiler needs to know is, what low-level language am I converting to? Even though today we can make a pretty solid guess that it's going to be the x86, i386 low-level language, which is Intel. But we also need to know what the target operating system is. Like when we looked at the code last time with the, we did look at the Hello World low-level code, right, last time. That one was written in terms of Linux, right? So we also needed to know about the operating system we were targeting, because we had to convert to low-level code in that architecture. So maybe low-level code for an Intel processor, but specifically considering that it's running on the Linux operating system. So we also have access to all the Linux magic tricks, their system calls they bring to the table, like syswrite and sysexit, for example, for the two we looked at. Okay, so a compiler needs to know about two separate things in order to do its job, which makes compilers very difficult to write. So the class that meets right after this is the language theory class, where we write a programming language. So in that class, what we talked about last time is the difference between writing an interpreter for a programming language. So this is kind of where it relates back to what we've been talking about in here. So if I were writing the Python interpreter versus writing the Java compiler, which is the harder task, the Java compiler by a huge margin. Although the Java compiler is an easier task than writing the C or C++ compiler, because the C or C++ compiler has a moving target for the architecture. The Java compiler, the architecture is the Java virtual machine 100% of the time. So I've taken one of these two steps out for that compiler. Now it's just a matter of the target operating system, but I don't even have to worry about that for the compiler, because since the Java virtual machine is ported to Mac, to Linux, to Windows, that guy handles the interpretation of the Java bytecode to that particular platform. So the Java compiler is actually kind of like almost like a cop-out type compiler. It's significantly easier to write than your traditional compiler would be. But if we're thinking about writing a compiler for C or C++, where we don't know what operating system this guy's going to run on, we don't know what architecture it's going to run on, because C and C++ certainly have compilers for MIPS and all these other processors you haven't heard of, you know, that are proprietary things or from other countries, a lot of embedded system stuff. So writing a compiler is very, very complex. And the evidence is in the pudding, right? We see only a relatively small number of compiled languages: C, C++, Java, C#, Objective-C, Swift. You know, you could probably find some weird ones out there, but I mean, those are the cool kids. And when you're really talking about programming in today's industry, the cool kids are actually what? Java, C#, C++, and C. And C is kind of like more for doing embedded system stuff, but you're really only looking at those four. You're only using Swift if you're doing Apple-y stuff. Objective-C, that was only Apple-y stuff too, but now Swift kind of overtook that. But you're really talking about four compiled languages that are used in industry, and you don't see new ones coming out each week. Or if you go over to the interpreted language side, you know, every 5 minutes there's a new interpreted language that hits the market. You know, only some of them bubble to the top as being very popular, like Python, PHP, JavaScript, all the JavaScript different renditions, Node.js, Angular, things like that. But you know, in a lot of those are just called JavaScript frameworks for web stuff. But you know, in any case, writing an interpreter is much, much, much easier. And you have plenty of interpreters that exist out there for kind of general purpose, or I'm sorry, domain specific type applications, where you might say, oh, well, I'm going to invent my own language because the things that I do on a very daily basis, really, I'm always doing the same 7 things in a row. And it's either this 7 things, or this 7 things. So maybe I'll create my own interpreter that maybe runs on top of Python. So we can call it like Mike's Python, where it actually is just a Python library that allows me to do one of my 7 combo moves, or one of my 7-step combo moves, and I could just give it a single instruction for doing those. And that's my new language. So interpreters are kind of a dime a dozen. So in that language theory class, in the undergrad level, we look at interpreters because we can focus on, how do you implement recursion? How do you write loops? How do you write conditionals? Like, how are those things actually implemented under the hood? In the grad program, we have a class on compilers. And what is interesting in there, you find out how much more complex they are, but you also realize at the end of the semester, in the language theory class in the undergrad level, you have a fully functional working programming language that was an interpreted language. In the at the end of the semester in the compilers course in the grad program, you have something that barely does anything because of how complex it is. Like, it was a lot of work to get almost nothing out of it, because you had to turn one line of code in your imaginary language. Like, we usually pick like a sample language like Java, and we pretend like the Java compiler doesn't exist. We write our own to turn it into, assembly language of some kind. But you see that those are difficult things. And then then you got to take the next step of having the compiler be optimized. Because the first step of a compiler is to turn high-level language into equivalent functional low-level code. That does not necessarily mean it's the most optimal version of that low-level code. So as compilers improve, what they start spitting out is more and more optimized low-level code to the point where it's maybe a fair statement to say that the job of a compiler is to make a bad programmer look like a better programmer at the low level, assuming they wrote accurate code. They just wrote it in a really slow way or something like that. All right. So questions about that? So compilers are kind of a complex thing. We're lucky that we just have one available to us, and it does its thing. Okay, so next time we'll start talking about more about the Java stuff. Remember, for first Bible homework is due by Sunday, midnight on Sunday, right? And then if you wanted to, you can start looking ahead at some of these slides if you want, but that's the only homework that's due for next week. Pretty quickly, we'll get into some of the newer stuff and actually start writing some code. We basically learned Java today in one class, right? And I'll go ahead and I'll paste the code in Slack that we wrote today. So you kind of have like a one-stop shop example of oh man, they added a whole bunch of stuff to the, that's not good. Now I can't find where's my code snippet? Oh, there it is. All right, I'll see everybody on Tuesday. Any questions from the online people? Comments, concerns, bribes? Sure. I don't care what you use, but I'll be doing all the examples in Eclipse. So if you like something else, that's fine. Just don't ask me questions about it. So, oh, no worries. Yeah, class will always be in this room unless something major happens. I will try to get one more table set up in the back, maybe.
I think I will just start doing it online. So totally fine.
Oh, are you sure?
Yeah, fine. Yeah. I realize the main thing that I want like, to be in person is if I need help, I can like come to your office at some point.
Sure.
And I think I can do that.
Yeah, absolutely. And or we can even just do we could do a Zoom meeting even if you wanted to, but make sure you ask questions online. As you saw, people typically don't, but just interrupt me.
I guess one of the questions I had, for one of my classes, there's some days I'm going to be online, some days I'm not going to be. And is it okay if I'm online on this class as well as my other class?
No, I don't care.
And in person or something like that?
Yeah, whatever. Yeah, Whatever's fine with me.
Yeah, some days I might do this class online, some days I won't.
It's fine. Oh, anything for me, or you're just chilling?
No, not really. Like, just trying to get stuff figured out for next month this year.